And the fourth and fifth types of chemical reactions are single replacement and double replacement. In a single replacement reaction, you start with usually an element by itself and a compound. And what happens is this element that's by itself replaces one of the substances in the compound, and that substance goes off by itself. So I have a substance all by itself plus a compound, and the A and the B switch places. Now the B becomes the substance by itself, and the A is in the compound. An example of this is aluminum plus iron oxide produces aluminum oxide plus iron. So in this example, the aluminum comes in and replaces the iron. Now that makes aluminum oxide, and then the iron goes off by itself, as we have over here. And I think I balanced this correctly. The last one is a double replacement reaction. In a double replacement, you have two compounds, each made of at least two different elements. So I wrote the general equation here. AB plus CD produces AD plus CB. So here, the A replaces the C replaces the A. There's two replacements there, so it's double replacement. And an example of this is copper sulfate plus potassium hydroxide produces potassium sulfate plus copper hydroxide. So remember, this SO4, that's a polyatomic ion, it's a sulfate ion, and this OH is also polyatomic. It's a hydroxide ion. So what's happening is copper replaces potassium to produce copper hydroxide. Potassium replaces copper to produce potassium sulfate. Now you've got to pay attention to the charges of the ions here. Notice this is just CuSO4 because copper has a positive 2 charge, sulfate has a negative 2 charge. But when you come over here, it's copper hydroxide, there's a 2 here because the copper has a positive 2 charge, right? So these subscripts that are over here don't necessarily translate. You got to pay attention to the charges. So this is just KOH, but this is K2SO4 because OH is -1, SO4 is -2.